Okay, so we're going to start with the other part of the activity. There's going to be the hand tool project. Actually, this meant to be just the water pump project, a part of the activity we have in the previous subject, where the students work in groups. Now we can work in a group as well. They were designing their own pump, or they can follow the pump we have as a standard one. The most important thing is that the students should learn how to take a simple stuff like this pipe and make it a pump. Now, what was the definition of the manufacturing processes in general? Set of operation. The main value for it is to make, well, I can say, make the unuseful thing a useful thing, or just add in value for the material. I can buy this pump, let's say for $5 for 2.5 meters. No, actually there's not $5 anymore. Let's say $12 for this 2.4 meters. Then I can cut it. Cut other stuff like this rod, which costs nothing, almost. Some of the rubber valve, make some of the pistons, valve, other stuff. And as simple things to have a water pump, which is going to be useful for the people who are in need for the underground water. When I say people in need underground water, is not only, by the way, in Africa or South America or third world countries. There was no third world countries, developed countries. Actually, even some areas in Australia, they don't have any access to the fresh water unless they get to do digging for the well and getting the water from there. And not all of them are rich people to buy the fancy pumps. Other thing we can do is in the hot area, they actually making their own water reservoir under the ground to eliminate, or actually to lower down the evaporation rate, and thus they're going to keep the water for a longer time. Once again, they're going to use some hand pumps to get the water out. So the pump we are going to go through, first we need to know what it is. We call it the two-stroke pumps. So we're going to have two valves here, and we're going to have this stroke with the main shaft. When we're going to pull the pump up and push it down, we're going to make a negative positive pressures, and this will cause the water to flow to the upwards. I think I have a GIF for that. Sorry, what is that? Where's the mouse? Oh, went to the other screen?
Yeah.
Okay, yeah, just make it one. Okay, so that's how the pump works. You can see that we have two valves. When you pull it up, the upper valve will be closed and pull the water up. When you push it down, okay, so you can see that we are going to have the sequence of the opening and the closing, causing a negative pressure here, positive pressure here, and the water will raise the level and pump to the outside. So, as simple as that. That's how the pump working. We are not going to worry about this principle now. The most important thing is how to make something working like that. So what we can see, what are the main components? We have the main body. We call it the cylinder. We're going to have the main shaft. We're going to have the main valve, and we're going to have the base valve. That's what we need to make. By getting some of the off-shelf items, try to add some manufacturing processes to them, can vary from a complicated one to an easy one. We're going to go through the discussion of every part we have in this pump and how we are going to make it using what we call it the manufacturing capability. I'm not going to tell you, oh, we're going to make this body made of casting, because most of the pumps are cast iron. I'm not going to tell you we're going to make multiple of these valves, because we can do the casting for them again. This something we need to discuss later as a part of the design for manufacturing. But as long as we are making one pump per team, we're going to reduce the manufacturing capability to what we have in this lab. So what we have in this lab is we have the driller press, we have the saw, we have manual saw, the rod cutter, the scissor, and we have the dies. We have some of the dice, I think the dice here for the threading, and we have the tapping head. So that's what I'm going to use to make this pump. Even for the part of the valve, back in the old days, I used to machine the head for the student. I'll let them use the turning machine to machine the head from the nylon. We had too many problems with that. The student started to do trial and error on this machine. The main problem we have with the nylon during the machining is what's happened to the nylon during the machining.
Would it melt?
Exactly, it's going to actually heat it up, so it's going to expand in the size, and when you try to put it in the part, you will find, oh, it's small. What's happened? I get it to the dimension, but it's shrink down. So we are going to actually try to apply something else this semester by making the massive production of all these valves. By the way, one of them is going to be step level, the other one is going to be just one level. Can you give me some suggestion on how to make these valves? If this was machining, can we have another option to do that? Shout, 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 so you can hear you on the phone. I'm recording, yeah. Yep. You will say 3D printing. That's a good option. What's the problem with 3D printing? They're not strong enough, unless we're going to make it as a metal. Can I give you another option? Okay, if I can 3D print it, I can use it as a pattern for casting, but I don't have the foundry to melt and solidify. So I can take the pattern, which made with the metal 3D printing, do the process called the thermoforming. Have you ever heard about the thermoforming? When you buy something new, like the food trays, actually they're made by thermoforming. Okay, I'm going to show you the machine upstairs. I'm going to show you that later on how this works. So we have the plastic sheet plastic sheet. We heat it up and we put it over the part with the negative pressure down. It's going to take the shape of the part. Then I can melt some resin, fill all these cavities. You're going to have multiple of these parts. Okay, so try to expand. Well, I always write down that in my module. Try to expand your knowledge. It doesn't have to read something. Maybe watching some simple videos and then try to add your logic sense on it. Okay, now, yeah, I can make it, well, the 3D print part is not strong enough, but I can use it as a pattern. The manufacturing time for the pattern is going to take 2 days. Well, no. Making the CAD, 5 hours, get the part, do the thermoforming, then the casting process is going to be for 100 or 1,000 parts at the same time, and the curing time is going to be 24 hours. But I'm going to get 1,000 pieces in 24 hours, even with the holes within. Okay, so that's another method to do that. Some of the washers, I can simply cut them. We have the roll of the rubber, and we can make the circle and try to cut it with the scissor. For this rod can be cut either by the saw, but for more accuracy, you can cut it with the rod cutter. How to cut the pipe? We have the pipe cutters, and we can cut on the saw machine. So the first thing we are going to do is, first you go to the to the canvas, and you will find the instruction for this activity. Second, I think that you need to work in a group of 3 students, and you are going to learn, because as I told you, we pre-cut most of the parts. You only need to do the minimum amount of the work to finalize them and assemble the pump. Maybe you are going to have the chance to test it on the test rig there in the back. Well, I said once again that most of the part has been pre-cutted, but we can once again cut it to give you the hands-on experience, and that's what I'm going to teach you today, how to use the different machines. I sent the videos earlier, but still, again, to have the hands-on experience ourselves. Just for example, I'm going to alter the length of this one. So you will learn how to do it. Or maybe we can get an extra material and start to cut it to the size. So let's take a look for what are the parts we have here. Okay, so of course, as I told you, the people who need it, actually, by the way, if you check this website, you will see that there's an international competition for the design of these pumps. Last semester, the students actually worked in a group of 5. It was all online thing, but they have actually a full study about what will be the best design. Each group need to submit 3 different designs, and then they will select one based on the best properties, the best manufacturing processes, the best cost, and the recyclability of the pump. So this is the pump. I have it now de-assembled in front of me. This is the pump, and consists of the following parts. We have the main cylinder, the main shaft, the main piston, the washer, the base valve. Well, that will be the top pipe. It's going to be sitting at the top after the T-junction. By the way, this is not my photo. I just stole it today from a previous report. So sorry for the quality, but actually I think it's acceptable. So as you can see that each part can be manufactured by a different process. This will be off-the-shelf item. I don't need to make it. I can use it as it is. What we call that? What we call, if I get to get the part off the shelf and use it directly, it's called standardization. I get to minimize the time of the machining because I get to minimize the cost in that case. So don't make something fancy if you can simply use it. But the most important thing is you have to know how to use it. If I get to put it that way, this will be wrong. I have to put it that way to be correct because the direction of the flow is going to be correct. So in this slide, you are going to see first the engineering drawings. Now for you, what will be the first thing you are going to do? Well, I know this will be available for you. You can check that available on the canvas. But as an engineer, you're sitting as a group and you decide to do something. You make a hand sketch. That's my pump, that's how it's going to work. If you want to actually make in different types of the valve, this will be your option. We still have 3 sessions for this. Yeah, we have 3 sessions for that. So you can have the time to design your own valve. But in all the cases, we're always going to have the standard one, and I will show you how we are going to make it in a massive production rate. So we start with the engineering drawings for every component individually. So we have the main cylinder. You can see that we have a length. This is just an example. You have different length for the pipes. You can cut your own length, doesn't matter. The main rod, the main piston, we have the pump handle where you're going to push and pull the main rod, and we have the foot valve, and we have the washers. We need to have the quantity actually should be mentioned here. The tolerances also should be mentioned here because we're going to have some mating parts while we're going to actually make the valve working, especially for the foot valve because this will be fixed in the pipe itself. So the tolerance should be actually plus, not minus, few fraction of the millimeters. So it's going to be fixed when I'm going to do the pumping. Otherwise, in my first push of the piston, this part will be taken off. So I came to the introduction of the tolerance. How can I also make, well, this one is fitted press, but the pressure is not going to hold the pressure. So of course I need to add something like bonding material, adhesive, to fix it in. Okay, what else do we have? This is not all the parts. We should supposed to have more parts. This is the joint socket. This will be at the on the side. This is off-shelf the item, off-shelf item, off-shelf item, and off-the-shelf item. That's you only need to have it drilling in the middle to pass the shaft through. So every part is going to have a different manufacturing processes. We go to the main cylinder. I'm going to have the 2.4 or 3.5 meters length of the PVC pipes. You can check the dimension because this will be very important to make the other components like the bottom valve and the main piston. So what we need to do first is when you do cutting, the most important thing is to do the measurement before the cutting. Well, actually, the simple rule of the cutting is you measure it twice, cut once. Because you don't want to measure a distance and then you cut it and you say, oh, well, I cut less than what's supposed to be or more what is supposed to be. That's meaning you're going to spend more time on doing the cutting. Usually the measurement is going to have less time to be performed. Then we can cut on the saw machine we have here. Once again, I took these photos from his report, so I didn't take the photo for our machine. What time we talked to each other? 12?
Yeah.
And I told you I'm going to make the presentation. I made it in 30 minutes. Or we can simply just using the saw to cut it. Which operation is going to be better? What do you think? Which one is going to be better?
This is the hacksaw.
This one or the hacksaw?
So using the machine or the hacksaw, what do you reckon is going to be better?
Machine.
Why?
It's a lot easier to use.
Okay, you will say easier to use, but I'm going to show you something that actually proves the opposite if you are not expert with it. So it will depend on your experience. I can damage the part by using the hacksaw, and I can damage the part using the critical saw. So depend on how I'm going to hold the part, and you will see that when I'm going to use the vise there. The same thing if you're going to use the vise here, and you add a lot of pressure when you press the pipe on the side, the shape will be elliptical, and we're going to have too many presses. While you do the cutting, you're going to have a crack happening. Same thing will be happening there. So we have two options to do the manufacturing for this part. We can also have the main rod. Actually, I should remove this one. So the main rod can be simply cut from this 6mm diameter rod. Once again, you need to measure to have it to the dimensions. We can use the rod cutters to cut that. I have the small one. I couldn't find the large one. I don't know why, but anyway, we always can find it. You can see that this one is going to require to have a thread on both ends. So we can use the thread gun to do this operation. These tools are available in the second drawer here. Anyway, this went one. That's the valve. That's meant to be something. I did that, he did this. But anyway, I cannot say this is wrong, but his idea was having something like a crescent here, because this will increase the flow of the water when you push the piston down. It didn't work fine, but anyway, we can simply cut it on the turning machine. We can 3D print the part, but I came out with another way to do it, which is simply just laser cut. What will be the problem with the laser cut? For the foot valve, it's had two different levels, right? So what do you think, how we can overcome this problem?
Separate pieces.
Exactly, separate pieces, and then simply we can drill the hole in the middle by the laser, so it's going to be accurate. So if I'm going to actually using the bolts and nuts to fix the two parts together, I have to be sure by adding some glue in the middle, so they're going to be solidified and became one part. Do you think that actually cutting that here in 2 minutes and do the gluing and leave them to solidify for 24 hours as a one part with very high accuracy dimension is better, or the 3D printing is going to be better? Remember that when I'm going to cut it here, I can have all the holes to be cut in accurate dimension. It's a clean manufacturing. Okay, so once again, think about that. It's up to you to go to the Pro Space and print your own parts if you want. And also I can allow you to use the small lathe machine to manufacture such parts if you want, because we do have the nylon material available for us. We may need some drilling and tapping. For example, this part is threaded inside. So we need to do some internal thread by using the tapping head. So the process is very simple. Just add some lubricant, do the drilling, then do the tapping, and you get to have the internal thread available. We can do the drilling either using the driller press for more accuracy, or you can simply use the hand tool. But usually I saw the student try to use that at high vise and they always keep going all the directions. However, if I get to do this part by laser cutting, maybe I don't need any drilling operation after that. The only drilling we are going to have is going to be on the drill press for this hole and for that hole. But the problem is, as I told you, I made these parts ready for you. So what we are going to learn there is we are going to get any material around and just try to apply the process of drilling on the drill press as an activity of using the tool hands. Okay, of course, this will be more accurate than that. How to make the washer? We can either cut it with the cutter or using the scissor. Both going to do the job. Just let me check if we still have stock material. I need to be sure that it's going to be available for you before we start this session. And finally, we have the foot valve, and the other components can be either off-the-shelf item, or we can simply use the same processes to manufacture them. So I think that's ending this slide. So by now, you can see that simple processing will make a product. If I'm going to collect all the items, it's going to cost me something around $15. The pump itself can be sold for $30. That's in our countries. The pump I showed you at the beginning of the session, they made it for $8 to $10 in Bolivia. Now, of course, there are differences in manufacturing and the cost in different countries. But again, to buy that in Australia for the cost of the whole pump in Africa, because they charge us more. Away from the quality, by the way. Okay. So what we are going to do is we are going to apply all the basics of the manufacturing skills we just watched in this video, and we are going to use the machines we have. We don't want to go outside and use external machine, because this is, as I told you, something about the manufacturing capability. Use what you have. If you would like to make something like a shaft and it's going to have two sides, you can do it on your milling machine, lathe machine, easy. You don't have to ask your boss, oh, well, I don't want to use this machine because it's going to take more time in manufacturing the same shaft, which has two sides. So go ahead and buy me the 20 spindle machine, which is going to cost you $1 million, and you're going to get the money back in 10 years. He's going to fire you, he's not going to spend the $10 million. Okay, so we're going to do the same thing here. We have all the tools. We are going to learn how to do the cutting today. The cutting for the pipes, the cutting for the rods, and the next session, as long as we have 3 of them, next session we're going to learn about the tapping and threading, and the last session, and also the drilling at the same time. And the last session we're going to assemble the parts and we try to make a pump working, at least by hand. We're only going to put it in the tank there. We try to pump some water just to prove that we actually got the concept of making the pumps. Now for the main piston, by the way, it should have very high accuracy because it's going to be slide inside, and this should keep the pressure with the walls. For this one, it does have a groove on the side, so we can put the O-ring, so it's going to close all the dimension. With the laser cutter, what the main problem we have with the laser cutter is the accuracy is good, but the problem we have with the laser cutter, yes?
Oh,
I thought that you have an answer.
I didn't have an answer.
What edges and like the timing piece?
Sorry?
What edges and the timing?
But actually, the thing you cannot see it by direct look. The cutting we have on the laser cutters will never going to be a straight line, a wall. It's going to be always inclined to the inside. So the one side is going to be larger than the other one. Maybe this is not going to be affect a lot, and also by the continuous refraction, you will have this part to be actually rooted and the things will be sitting. It's something like you have a new engine. That's why when you buy a new car, they tell you, oh, drive the first 5,000 kilometers with the speed less than 70 kilometers per hour, because the engine actually taking the shape, so you don't have to go for a very high RPM. Oh, that's the old school. I don't know. You keep doing that, or you're using the car for 2 years and then dump it. So yeah, so that's what we're doing, and that's what we're going to learn on how to do the parts. So we should start first with the activity of cutting the parts.
About team formation.
About what?
Team formation. How many teams?
Oh yeah, they can work now together just to get the skills, and within the time they will know each other further and start to form the teams. So yeah. Now, do you know each other? That's the problem we have. They don't know each other too much, but they will introduce themselves to each other and they start to form the teams over 3, which are going to work together to assemble the pump and test it. Okay, so I'm going to stop the recording and you can